Alright, we continue with the production geochemistry. What is your task? We have now, you need to actually perform your task to monitor reservoir flood, to allocate commingled production, to identify completion problems, to prevent sludge, aspartame or mineral scale deposition, and lastly, you need to control the environment for field abandonment. Alright, for the specific tasks here to monitor the reservoir flood is we have two tasks for you. First is by identifying the uneven progression of the flood prime through reservoir. How does this uneven progression occur? Simple, because there will be different injection momentum of injectant at certain part of the reservoir, and some part of the reservoir may have rapid injection, which may lead to the uneven breakthrough causes by loss of oil, or causes the loss of oil in bypass sections of reservoir and reduce ultimate oil recovery. So the technique that you will use to overcome this problem is by using oil geochemistry and water geochemistry. So there will be steam flood or water flood or gas flood that will occur in the field. So to prevent steam and water flood, you need to use the changes that occur in the composition of produced oil over time to actually identify the portion of reservoir being impacted by the flood and to estimate the relative production from specific reservoir interval. Right, for the gas flood, usually industry people will use the compositional data of the injectant, the gas solution, the solution gas and the produced gas to actually assess the percentage of the injected gas present in the produced gas. Alright, the second task to monitor reservoir flood is by minimizing the formation damage. So this formation damage is actually caused by the interactions of the injectant with reservoir fluid and rock, and eventually will lower or will give impact on the give impact on the injectivity performance, where it will reduce the performance, and it also will lower down or reduce the producibility of a reservoir. So how does the formation damage occur? Okay, in the case of water flood, the formation damage occur due to the reaction of injectant with reservoir minerals and a reservoir brine, which will resulting in the precipitation of secondary minerals and swelling of clays. This precipitation may clog the pore throat and reduce the injectivity. So the technique to avoid this type of formation damage is by analyzing the composition of injected water, reservoir brine and reservoir mineralogy. Meanwhile, in the case of gas flood, which occur due to dissolution of injected gas into the reservoir oil, which later will or may reduce the solubility of solid bitumen in the oil, thus will resulting in the precipitation of aspartame and high molecular weight paraffin. So the technique to overcome this gas flood in the field is by doing the core or by conducting core flood experiment in laboratory, identifying the formation width of organic precipitate, and by identifying the chemical modifier to injectant to actually prevent the formations of organic precipitate by increasing the solubility of aspartame and high molecular weight paraffin in the oil and gas solution. Alright, the second task of a production geochemist is to allocate commingled productions. What is commingled production? Is actually mixes of multiple oil in a produced oil. So how it occur? Simple, there will be three processes that cause the commingled production. So first, by different process of reservoir alterations which occur after the oil enter the reservoir, and it will later do not operate the oils that enter the reservoir which do not operate at the same rate and extent in each compartment of reservoir. The second one is by different of compartment in reservoir. meaning that if there are two separate compartments of reservoir, it is very difficult to achieve precisely the same homogenized composition of oil, even if the oil from the same source rock. This is because oil that generated from a source rock also tend to have different composition due to slightly different in the time of generations and maturation history. The third causing effect of the coming liquid production is because of different source rock. There may be more than one source rock that has generated the oil and contribute the oil to an accumulation. So therefore, the composition of oil in an accumulation may also differ due to different time of generation and migration path. Alright, so the specific tasks to allocate this coming lake production are by determine the contributions of each oil in the mixes. Second, by assessing relative production from multiple pay zones in a given well. And third, by detecting zone performance problem at any point during the life of a well by monitoring the production of multiples of zone frequently over a long period. So the method that usually industry people use to allocate the coming gold production is by using oil geochemistry. Alright, the third task for a production geochemist will be identifying completion problems that occur in the oil field. So the common problem that occur in oil field are such as tubing string leaks, communication between zones behind casing due to poor injection or poor cement jobs, and second, ineffective simulation of a given interval. So to identify this common problem, usually they will use oil geochemistry on the same sample of oil type that have been used in assessing reservoir compartmentalizations and coming gold production. So methods that they usually use is by using oil geochemistry. Alright, so the last task for a production geochemist is to prevent sludge, aspartame or mineral scale deposition. So what happens if we have sludge, aspartame or mineral deposition in our during tubing? It will impact on reducing the flow line performance and the producibility of the reservoir. So the origins of this formation is caused by the various well additive, both that will cause actually oil and water emulsion. Second, by difference of coming gold in a flow line where it causes the precipitation of aspartame, and it caused also by the dissolution of injectant of the oil, and lastly it caused by the precipitation of mineral scales because of the reactions of injectant and rock mineral that usually occur in flow line, valve and gauge and other surface equipment. So the technique actually to prevent this thing to precipitate is by using or by treat our piping using hot toluene or acetylene washes, and also conduct core flood experiment by identifying the effect on the additive on the reservoir oil, and then by identifying chemical modifier to prevent precipitation, which this can be added to the production steam so that it will increase the solubility of those precipitation, and lastly by identifying the mixing of fluid geochemistry. Alright, so this is the end of the CLO1 or regarding the introductions of petroleum geochemistry. So as a petroleum geochemist, we have a task to actually assess the source rock, reservoir, and also we have to actually help the exploration team to encounter any problems. For the source rock geochemistry, normally exploration geochemists and development geochemists will take over the issues that usually will arise. Like for example, they frequently will ask how oil is generated, when oil is generated, where is oil generated, what characteristic of oil is generated, So for the reservoir geochemistry, normally a geochemist or normally development and production geochemists will play a role to actually encounter problem on regarding the volume of oil generated, and then the type of oil exists in that field, where how many number of lateral compartments, and how many contributions of each reservoir, and is there any tubing leak or cementation leak occur in the production area. Okay, and at the end of the day, to actually validate all the above question here, we need to actually come up with a few analyses, like for example oil concentration, oil circulation, to actually validate the presence of the same oil or different oil in that field. And we also need to assess the petroleum system of that basin. Alright guys, that's end of the lecture. Thank you.